So there's a point A, there's a point B. Let the wind blow with a velocity Vw. What is Vw? Velocity of wind with respect to ground. I need not to mention that. Then the aeroplane. Hope I think I can draw aeroplane. No, it is going to move towards right with a velocity. So what all it will have, VAW, velocity of aircraft with respect to wind, like how velocity of swimmer with respect to river. So what all the speedometer of the aeroplane that indicates, it will indicate the velocity of aircraft with respect to wind. So you just call the pilot and ask him with what speed he is moving. He says that, let's say 50 km per hour or 100 km per hour. With respect to what? With respect to the wind it is. With respect to ground, you don't know. So the speedometer of the aeroplane, what it indicates, it measures the speed of the aircraft with respect to wind. So this is a very basic instruction. Let me write here. Note. So the speedometer measures the speed of aircraft with respect to wind. If the wind doesn't blow, okay, fine. If the wind blows, then always the speedometer of aircraft will indicate the velocity of aircraft with respect to wind. With the help of this, we are going to calculate the absolute one. Let the distance from the point.
Sir, so if there is no wind,
Then VAW will become equal to VA. Simple idea, no?
okay, sir.
So in what direction the wind is blowing? From A to B. So what is the first case I'm discussing is like a wind blows from A to B. Wind blows from A to B. So the wind is going to blow from A to B. Then we are discussing this situation. Now, I want the time taken by the plane to move from A to B. So what is A and B? A and B are the points with respect to ground. Destination. There's like a source, there's a destination. Then what is the time taken? For that, I should know the absolute velocity of the plane with respect to ground. I think the source and destination, they must lie on the ground. Agreed? So therefore, the velocity of aircraft with respect to wind should be equal to velocity of aircraft with respect to ground minus velocity of wind with respect to ground. Velocity of aircraft with respect to ground, that is what VAW, we know it. Anything towards right, let it be positive. Velocity of aircraft with respect to ground, this is I'm going to call just VA. This we don't know, leave it, and this is VW. So velocity of aircraft equal to, so what is the time taken now to move from A to B? It should be equal to L by VA. There is a time taken by the aircraft to move from A to B. Similarly, if the wind blows opposite to the direction of motion of the plane, the plane will start again, it will be source, this will be destination.
Sir, what is L in this formula, sir?
Length, no. How do you not saying source to destination? Huh?
Okay, sir.
The distance from source to destination. Okay, there's a aircraft, it is moving with a velocity with respect to wind, and the wind blows opposite to direction of motion of the plane. Your second case, wind blows from B to A. Then again the formula VAW equal to VAG minus VWG. So this is positive, this we don't know, this is VW. Any why negative sign? Anything directed towards right is positive. Then VAG or just only VA, this should be equal to VAW minus VW. Then in this case, what is the time taken will be L by, I think this is a quite natural, no? Time taken by the plane to move from A to B. See now, okay, we have sophisticated machines, everything. Just go back 50, 60, 70, 80 years back, no? The effect of wind was something very, very important to save the fuel. They were using all these methods like how do, shall we go against the wind? No, if the wind is blowing, okay, then one better cancel the flight. If the wind blows with a high speed, then what is the problem? To reach the destination, more time. So therefore, what happened? They used to wait for the wind to get subsidized. After wind speed decreases, then they used to go for this one. All these were the problems what we had some 50, 60, 70 years back. Okay, now we got a very good machines. We are able to overcome all these difficulties. But even then, there'll be impact. See, I think the whole formula just revolves around this. I think from the on Monday we started the discussion and just it was revolving around this one only, no? V12 bar equal to V1 bar minus V2 bar. Only the terms you should understand here. The source and destination will be there on the ground only. So altogether, to move from A to B, what is the velocity of plane with respect to ground? That's what needed. And this is not measurable. So what is measurable? VAW is measurable. The speedometer measures the speed of aircraft with respect to wind. So what is that? VAB. Speed of aircraft with respect to wind. That is VAW. VA is not measurable. VAG or VA is not measurable. Getting the idea? The same thing, riverboat conditions. Suppose say if he goes from up and down, means if he moves from like a to B and B to A, to and fro trip, usually we'll call, no, to and fro trip. The wind will continue to, the wind will change. So like a to and fro trip. Now the wind I made opposite that one. Suppose if the wind blows in same direction, and if he goes from B and B to A comes in, then the direction of wind will be opposite to the motion. In that case, so we can just add up these two, to and fro journey. I just discussed very specifically here. Wind blows opposite to the direction of motion of aircraft in the direction of motion of aircraft. Then will there be any impact on the time taken to move from source to destination? Yes, it will be. If the velocity of wind is 0, then VAW will become equal to VA. It will become actual velocity. But there will be wind. Okay, write it down. We'll take the next case.